Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 129, for broadcast on the 2nd of December 2020. Coming up on SpaceTime, a fossil galaxy hidden in the heart of the Milky Way. A new study claims Venus hasn't lost all its water into space, and the European Space Agency's Sentinel-6 spacecraft launches into orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a fossil galaxy hidden in the depths of our own Milky Way galaxy. The findings, reported in the monthly notices of the Royal Astronomical Society, will further change science's understanding of how the Milky Way grew into the galaxy we see today. It's thought this newly discovered fossil galaxy may have collided with the Milky Way some 10 billion years ago, when our own galaxy was still in its infancy. Astronomers have named the fossil Heracles, after the ancient Greek character of mythology who received the gift of immortality when the Milky Way was created. The remains of Heracles account for about a third of the Milky Way's spherical halo. But if stars and gas from Heracles make up such a large percentage of the galactic halo, why hasn't anyone noticed it before now? Well, the answer to that question lies in its location deep inside the Milky Way. To find a fossil galaxy like this one, astronomers had to look at the detailed chemical makeup and motions of tens of thousands of individual stars, using data from the Sloan Digital Sky Survey's Apogee or Apache Point Observatory Galactic Evolution Experiment. That's especially hard to do for stars in the centre of the Milky Way because they're hidden from view by clouds of interstellar gas and dust. Apogee lets astronomers pierce through the veil and see deeper in the heart of the Milky Way by taking spectra of stars in near infrared rather than visible light, which gets obscured by all the gas and dust. Over its 10-year observational life, Apogee's measured spectra for more than 500,000 stars across the Milky Way, including its previously dust-obscured core. The study's lead author, Danny Horter from Liverpool John Moores University, says examining such a large number of stars is necessary if you want to find unusual stars in the densely populated heart of the Milky Way, which is a bit like finding needles in a haystack. To separate stars belonging to Heracles from those of the original Milky Way, Horter and colleagues used both chemical composition and velocities of stars measured by the Apogee instrument. Horter says that of the tens of thousands of stars they examined, a few hundred had strikingly different chemical compositions and velocities. In fact, these stars were so different they could only have come from another galaxy. By studying them in detail, astronomers were able to trace out the precise location and history of the fossil galaxy. Because big galaxies are built through the merger of smaller galaxies over time, the remnants of older galaxies are often spotted in the outer halo of the Milky Way, a huge but sparse cloud of stars enveloping the main galaxy. But since our galaxy is built up from the inside out, finding the earliest mergers requires looking into the most central parts of the Milky Way's halo, which are buried deep within the galactic disk and bulge. Because the stars originally belonging to Heracles account for roughly a third of the mass of the entire Milky Way halo today, it means that this newly discovered ancient collision must have been a major event in the galaxy's history. And that suggested the Milky Way may be unusual, since most similar massive spiral galaxies appear to have had much calmer early lives. This is SpaceTime. Still to come, a new study claims that despite being the hottest planet in the solar system, Venus appears to have lost little of its original water content to space over the past 4 billion years. And the European Space Agency's Sentinel-6 spacecraft launches into orbit. All that and more still to come on SpaceTime. A new study suggests that despite being the hottest planet in the solar system, Venus has lost very little of its original water content to space over the past 4 billion years. The findings by Moa Persson from the Swedish Institute of Space Physics contradicts popular hypotheses about the fate of Venus's water. The thesis is built on analysis of how the solar wind, a stream of charged particles constantly flowing out from the Sun, affects the Venusian atmosphere, causing atmospheric particles to rip off and escape into space. Persson analysed data from the Aspera 4 instrument aboard the European Space Agency's Venus Express spacecraft. She describes the surface of Venus today as being comparable to hell. It's extremely dry and has temperatures of more than 460 degrees Celsius. But she says historically the surface was once far more hospitable, with a wealth of water that could have reached depths of several hundred metres if spread equally over the entire surface. Now, while the water has disappeared from Venus' surface today, Persson suggests that only a few decimeters of water has actually escaped into space. Her findings are based on measurements of charged particles or ions in the vicinity of Venus. Persson says on average 2 protons escape from the atmosphere of Venus for every 1 oxygen ion that escapes, and that indicates a loss of water. But variations in the solar wind and solar radiation affect how many ions escape overall, and Persson found that the number of escaping protons varies over the solar cycle. It seems more protons escape during solar minimum than during solar max, because many protons return to Venus during solar maximum. As to the number of escaping oxygen ions, well, that's mostly affected by variations in the solar wind. Persson calculated how much water has escaped Venus in the past, and how the ion escape is affected by the solar wind variations today, and how the solar wind itself has changed over time. As well as being Earth's nearest planetary neighbour, Venus is also considered to be Earth's sister planet. That's because both are virtually the same size with similar mass and diameter, and both were formed under similar conditions in the same part of the solar system out of similar materials. But for some reason, Venus has suffered a runaway greenhouse effect. Its surface is now scorchingly hot enough to melt lead. The planet shrouded in kilometres thick opaque clouds, which rain down droplets of metal-eating sulfuric acid. And those thick clouds, well, they're so heavy, they're literally crushing Venus's rich carbon dioxide-based atmosphere, acting like the lid of a pressure cooker and giving the planet a surface air pressure some 92 times greater than the average sea level surface pressure on Earth. Venus orbits the Sun every 224.7 Earth days. But unusually, Venus rotates on its axis in retrograde compared to most of the other planets in the solar system, meaning on Venus the Sun rises in the west and sets in the east. And it's a slow rotation. A day on Venus takes some 243 Earth days, meaning a Venusian day actually lasts longer than a Venusian year. This is SpaceTime. Still to come, the European Space Agency's Sentinel-6 spacecraft launched into orbit, and later in the science report, a new study questions how well face masks really work at limiting the spread of COVID-19. All that and more still to come on SpaceTime. The European Space Agency's Copernicus Sentinel-6 satellite Michael Freilich has been successfully launched into orbit aboard a SpaceX Falcon 9 rocket from the Vandenberg Air Force Base in California.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of Sentinel-6 Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal.
Power and telemetry nominal.
Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. Beautiful clear skies there from Vandenberg on the ground.
Stage separation confirmed. Stage 1 boost back burn is started.
And that second engine looks like it has lit.
Burn separation confirmed. And stage 1 boost back burn shut down.
Second
Both
stage.
vehicles continue to follow nominal trajectory.
Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. Second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes, and then there will be a long coast phase today, and then we will have a very short, a relatively short second burn.
Stage 1 entry burn is started.
All right, so call for the entry burn there.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out, and that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad back behind. But we have a clear shot of it coming down onto the pad. That is the engine cutoff of stage 2.
Perfect.
Just there's the sonic booms we talked about, and touchdown.
And Falcon 9 has landed at LZ4, landing operator speed into 11.100 on recovery 2.
The 1.2-ton Sentinel-6 uses advanced radar altimetry technology to monitor ocean topography and study sea level rise caused by global warming. Ultimately, the Sentinel-6 mission will comprise 2 identical satellites, the second to be launched in 5 years' time. The spacecraft are continuing the work of the French-US Topex Poseidon and Jason series satellites, which have served as reference missions over the past 30 years, together with the European Space Agency's earlier ERS and Envisat satellites, as well as today's Cryosat and Copernicus Sentinel-3 missions. Combined, these have shown beyond any doubt that Earth's average sea level has risen by an average of 3.2 millimeters every year. And more alarmingly, this rate of sea level rise has been accelerating over recent years, with the average rate of rise now increasing to around 4.8 millimeters annually, all of it due to climate change. Sentinel-6 makes its measurements using a radar altimeter, which works by measuring the time it takes for radar pulses to travel to the Earth's surface and then back again to the satellite. Combined with precise satellite location data, the altimetry measurements yield the height of the sea surface. The satellite's instrument package also includes an advanced microwave radiometer that accounts for the amount of water vapor in the atmosphere that affects the speed of the altimeter's radar pulses. Sentinel-6 is the first to employ synthetic aperture radar for altimetry reference. The radar instrument operates in a continuous burst mode, simultaneously providing conventional low-resolution mode measurements and the improved performance of synthetic aperture radar processing. To ensure that the data time series is continuous despite the change of instrument technologies, Sentinel-6 is spending its first year in orbit flying just 30 seconds behind the Jason 3 satellite. That way, measurements from the two can be compared. Orbiting at an altitude of over 1,300 kilometers, Sentinel-6 provides sufficient measurements to map the height of the sea surface over some 95% of the world's ice-free oceans every 10 days.
Wherever you live on this globe, the oceans will influence you in some form or the other.
We are answering those really interesting and hard questions that we all have about our universe and our planet.
My name is Séverine Fournier, and I'm observing our changing oceans from space.
I'm Shannon Statham, and here at NASA JPL, I help prepare Sentinel-6 for its journey to space.
My name is Shailen Desai.
My name is Parag Vaze.
My name is Ben Hamilton, and I'm studying sea level rise from space.
Sentinel-6 is all about water. This sort of top half of the satellite houses the main instruments.
We have the altimeter, we have the radiometer.
Sentinel-6 is a collaboration with NASA, NOAA, the European Space Agency, and also EUMETSAT in Europe to measure sea level.
And it's specifically capturing the height of the ocean.
The satellite is actually emitting a signal.
And that signal is bouncing back.
It measures the time it takes for that pulse to get back.
So we've been measuring the height of the ocean since the beginning of the 90s.
I've worked on Topex Poseidon, Jason 1, Jason 2, Jason 3.
We really need that long duration observation.
And Sentinel-6 is going to allow us to continue that record.
So that we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It's not just scientific curiosity. It really impacts the daily lives of people and their ability to plan for their future.
I see pictures of coastal inundation and flooding.
You start to realize the importance of understanding what sea level is doing now. We can use that understanding to know what sea level might be doing in the future.
Seeing that come to fruition is a personal satisfaction and an emotional satisfaction.
Scientists around the world are using this data to help people.
The importance of this project and where it touches is on all walks of life all across the world.
From space, it's just one planet.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has raised some interesting questions about how well face masks really work at limiting the spread of the COVID-19 coronavirus. A report in the journal Annals of Internal Medicine claims a randomized trial of more than 6,000 people in Denmark suggests face masks have only a limited additional benefit in stopping the virus spread for people who are already following good social distancing and hygiene recommendations. In other words, keeping at least 2 meters away from other people, keeping your hands away from your face, and washing hands regularly. The study, known as the Danmask 19 trial, asked people to follow existing public health measures, either with or without the additional recommendation to wear a surgical mask when outside the home. It found that after a month, 1.8% of people in the mask group and 2.1% of people in the control group developed infection. The authors stressed the findings should not be used to recommend against wearing masks, because the trial didn't test the role of masks in stopping the transmission from an infected person to others. The deadly COVID-19 coronavirus has now killed more than 1.5 million people worldwide and infected more than 60 million others since first spreading out of Wuhan, China, a year ago. A new study claims overweight people who eat healthy diets have a lower risk of dying from cardiovascular disease compared to those with unhealthy diets. The findings, reported in the journal PLOS Medicine, measured how closely people kept to a Mediterranean diet rich in whole grains, fruits and vegetables, finding that those who ate a healthier diet were at a lower risk of dying regardless of their body mass index. The authors suggest it's important to shift our focus onto healthy eating, but they caution that being overweight still carries its own health risks. A new study has shown that both global warming and pollution have a similar impact on coral reef fish. A report in the journal Nature Communications has shown for the first time that human-induced stress such as global warming and pollution affect coral reef fish development and survival due to disruptions to an endocrine pathway. The findings by scientists at Griffith University suggest that even exposure to low levels of temperature change and pollution, which on their own might have little or no detectable effect, are disrupting hormone processes when experienced together. Paleontologists say an ancient ancestor of modern alligators and crocodiles had the sort of smile you definitely wouldn't want to see. A report in the journal Vertebrate Paleontology says Deinosuchus could grow over 10 meters long, with teeth as big as bananas. Deinosuchus, meaning terrible crocodile, even outweighed the largest predatory dinosaurs living alongside them between 75 and 82 million years ago. The researchers say the fossil records are showing that Deinosuchus were very opportunistic hunters, who liked to chomp down on turtles, dinosaurs and any other creature silly enough to get too close to the water's edge. It seems some things haven't changed over the eons of time. Chinese smartphone brand Oppo have unveiled the new X 2021 prototype rollable smartphone, which they say could be the shape of things to come for alternatives to folding phones from Samsung and Huawei. With the details, we're joined by Alex Reut from ITY.com.
Well, this is a new prototype phone called the X 2021. And just looking at it, it looks like a standard, 5, 6, 7-inch large screen phone. But if you go and type in Oppo, O-P-P-O, X 2021 into Google or Twitter or YouTube, you'll see these videos of the phone just sort of very smoothly and subtly getting wider, and you sort of wonder how the hell is it doing that? Well, what's happening is that it has a rolled, like a scroll inside. Obviously, the scroll is not very long because it only goes out a certain amount, but the phone unscrolls and little motors inside push the edges of the phone outwards. And so you go from a standard size screen to one of the ones you might see on the Galaxy Fold, which is sort of a bigger, more tablet-y sort of screen. And the way that it expands out so gently, it looks like magic. It's like something transforming out of Transformers or Harry Potter. And it's very cool. And it solves the problem of having the crease in the middle of the screen, which is what you see on the Samsung Galaxy Fold. You have this crease. It's impossible to miss it. And this gets rid of that problem altogether. Now, it's just a prototype. Don't know if it's going to really appear next year or not, but there's already been some seen in the wild by engineers that's saying that there's 100,000 curls or unrolls that it can do. It should last for at least 5 years. And no doubt this is just the beginning of many more experiments in amazing screen technologies that go from something small to something much larger.
Now, anyone who has Outlook will have noticed a few problems over the past week. Microsoft have introduced a new update, prevented Outlook from working with some formats, and as a result of that, it just died. It just stopped updating, and unless you were expecting new emails to appear, and you wouldn't have noticed there was a problem, but that's what happened.
So, well, this was to do with Telstra, Australia's largest telco, the equivalent of AT&T in the US. And for some of their customers using something called the Telstra Apps Marketplace, they had various partners of theirs help people to sign up to websites and get email. And this was being done through Telstra's business services. And they'd set up a business POP and SMTP server, which is one of the ways that you can access your email from your mail server. And what Telstra had done was that, this system has been in place for over a decade, but they decided that they were going to move everybody over to Microsoft 365, or Outlook 365. And then a few days later, their email just stopped, and they had no idea why. And I went to my friend's place to try and figure it out. And so I went on a bit of a scavenger hunt to try and find out, ringing domain name operators and Telstra themselves. And, one arm of Telstra didn't know what the other was doing. But so many people had been affected by this change that Telstra was saying that it was going to take 2 weeks before you'd get a phone call to help you set yourself back up into Outlook 365, their exchange service. And then when my friend got a phone call on Thursday, he has to wait another week before they'll sort of be able to help him. So I've had to set him up on a Gmail in the meantime. But this sort of major mass email migration that's presumably affecting tens or hundreds of thousands of users, if it's not properly handled like you would hope and expect, that you can dislocate the email services of huge numbers of people.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpacetimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.